first real lecture. But before I get started, I kind of want to talk about enrollment a little bit and a couple other minor things. So I sent a list to Michael David, who's the course scheduler, of a few people from the wait list who gave me survey responses, said I wanted them to add. I haven't heard from him yet. I assume that's because he's busy making sure all the other classes are good, that are more important than mine. So just keep coming, and we'll get you guys in. It looks like we are not overcrowded like we were last on Thursday, so I think we can fit everybody that wants to keep coming. So we'll take care of it. Don't worry about that. We'll get that taken care of, hopefully in the next couple weeks. Okay, so. Teams. Oh yes, I mentioned the project last week, kind of really just briefly. Just to kind of get you guys thinking, we strongly encourage, we allow you to do projects in groups of 1 or 2. We very strongly encourage groups of 2 because we generally think that the projects turn out a lot better if people work in pairs. We're not going to force you to, but we really do highly encourage you to work in pairs on the project. We won't really ask anything more about the project until halfway through the semester when we want your project proposal. So just kind of start thinking about that, think of some ideas you might want to work on. But you have a few weeks to worry about that. So just kind of have that in the back of your mind while we go through some of the new material. Any other general questions before I start? Yes? Okay, sorry. I'll make sure to speak louder. Thanks. Okay. We good? Okay, so let's get started. Today is our first of 2 parts of learning the basics of Objective-C. So I thought I'd start with a little history of Objective-C. Objective-C started in the early 80s by 2 gentlemen called Brad Cox and Tom Love at their company called Stepstone. They were really excited about the possibility of object-oriented software design, and they were really impressed with Smalltalk, which had just recently come out. And they started by they also wanted the software to be very portable, so that they really liked C for its really, you can compile it on anything. So what they wanted to do is they wanted to basically bring this object-orientedness that Smalltalk introduced to C. So they initially wrote their own pre-compiler for C. The initial version was called OOP-C, which is object-oriented pre-compiler. It just began as a C preprocessor, and eventually it became a full language. In 1988, Next licensed Objective-C from Stepstone and used it to develop their OpenStep and NextStep operating systems. When Apple acquired Next in 1996, they acquired the rights to Objective-C and continued to develop it further. Just kind of some high-level features of Objective-C. It's a simple extension to C, which means that any legal C code is also legal Objective-C code. It has the low-level efficiency and interoperability that C gives you, but it also has a really, really dynamic runtime like Smalltalk. It's statically typed like C, but that's actually optional. We'll talk about today. There's a way to optionally type things. Generally, you want to statically type things, but there's cases where it's not, where static typing doesn't make sense, and Objective-C allows you to not have to statically type. Unlike, for example, C++, Objective-C is a single inheritance object-oriented language, much more like Java. It allows multiple protocols, which I think we'll talk about next week or next meeting. But it's a similar concept to a Java interface. So just a little bit more about Objective-C's dynamic runtime. Like I said, it's very dynamic. You can actually add and subtract methods and replace methods at runtime, which is pretty cool. Objects are always allocated on the heap. And there's some memory management techniques that we'll talk about next week about how to make sure that things get released off the heap at the right time. Don't worry about that for this week. And the one really powerful thing I think is that message, and I'll talk about what a message is in a minute, but basically method dispatch in Objective-C is completely done at runtime. It's all, no method. It's not like a C++ where everything's bound to some swizzled method name and everything's fixed at compile time. All the method calls are determined completely at runtime, which is pretty cool because it allows you to swap objects underneath, and it still works. So, just as a quick poll, how many people have not written an object-oriented program before? Okay, that's about what I expected. So I'm going to do this really quickly just to make sure that we understand the terms of an object-oriented language. So the basic term is a class, which you can kind of think of as being the blueprint for an object. It kind of defines what kind of things an object can do and what objects it contains. Like I said, it groups data and methods together. An instance is a particular allocation of a class. It's one particular batch of memory that represents this particular object. There's always one instance in every class, but there can be many, many instances. Sorry, I misspoke there. There's one class definition, but there can be a whole bunch of instances of that class. A method, as we know, is a function that an object can do, and instance variables are pieces of data that objects hold on to. So, Objective-C handles object orientation perhaps slightly differently from what you've seen with, say, Java or C++. So Alan Kay, when he was developing Smalltalk, he says he thought of objects as being like biological cells, or individual computers on a network that can only communicate with each other by sending messages between each other, which is how Smalltalk operates. It uses a message passing system, which is part of Objective-C as well. So we'll talk about in a minute about what message passing means. But the main idea is that it's not like C++ or Java where things are bound, well maybe not Java so much, but C++ where methods are bound at compile time and determined there. Like, we'll see how that works. There's a couple of other terms. C, for example, is a procedural language where you have functions that operate on data. And object-oriented languages, like I said, are objects that communicate with each other by sending messages to each other. So this is sort of the typical diagram of what an object looks like. It has some internal state that it usually likes to keep private, and there are methods that allow you to operate on an object, possibly changing the internal state of the object, and possibly allowing you to access that internal state. But ideally, the object, nobody outside can actually literally see the internal data. We often call this data encapsulation, and it is considered good style. If you make all your variables public, that's often considered bad style. So here is an example of kind of a high-level interaction between two objects that are sending messages to each other. So we have this object in the lower left here. It sends a message to this other object, and incidentally in Objective-C that it actually does send the literal string of the message name, which is pretty cool. And then assuming that object actually responds to that message and knows what to do when it gets that message, it perhaps returns a response. It might be a void method, so it might not actually return anything, but it might do. But hopefully it'll do something. And so this is how objects communicate. So a few more OO terms. Polymorphism is the idea that you can have different objects that have the same interface. So, for example, if you are doing a drawing program and you have circles and you have rectangles and you have triangles, and they all know how to draw themselves. But when you're drawing objects, you don't really care what kind of shape they are as long as they know how to be drawn. That's an example of polymorphism, that they all have the same interface, but they're totally different objects. And inheritance, I hope you all know, is a hierarchy of classes. So classes can inherit behavior from their parents, and they can also replace or override the behavior that their parents give them. Okay, so hopefully that's pretty all clear to all of you. Any questions about object orientation? Okay, that's kind of what I thought. So I'm going to kind of really quickly show you, and not really explain how they work just yet, but this is kind of what some messages look like in Objective-C. These are declarations of methods. So we have instance methods, which are marked by beginning with a minus sign, and we have class methods, or static methods if you're a Java person. They're marked with a plus sign at the beginning. In parentheses, you have the return type, and then you have the name of the message. So we have a message here called init, we have a message in_name, which returns a string object. We have a width, which returns a float. I'll talk about what it is in a little bit. Don't worry about that for now. Okay, so let's look at some messages. This is a really simple message. So the way object calls are done in Objective-C is this is actually exactly like Smalltalk, except they added square braces to make it look a little bit more clear. The idea is you have an open square brace, the object you want to send the message to, followed by the message that you want to send. Which looks pretty straightforward when the message doesn't take any parameters. Where people really start to dislike this is when you start passing parameters, and it'll look really weird. I swear, it'll look really weird, but it will make sense, and you'll learn to like it.
And so another way that you can think of those two that you'll also see in the documentation a lot is target and action. The receiving object and the message, or the target and the action.
Okay, so the second message is an example of a message that takes an argument. So again, we start with the open square brace. We start with the object you want to send the message to, the name of the message, followed by a colon, which indicates that you're passing in an object along with the message. In this case, we're just passing in some other object called argument. But we can also pass in multiple arguments, and this is where it's going to look really, really weird to most people. Rather than having a one-part message name, the message name is actually split across the parameters. So we have this, the name of this message, as I would read this, is message more message. Obviously, it's not very descriptive. Real messages make more sense. So the kind of cool thing about this is that this allows you to embed in the method name what parameters are what. The practical upshot of this is that when you write Objective-C code, it looks really, really readable. It looks almost like English. And I think I have some examples of some real messages with non-generic names. But maybe just to kind of clarify, hopefully most of you are familiar with Java. That's the example I've been using. So these two are basically equivalent. We have some object we call, and in Java we'd say dot, the name of the method, and paren for no arguments. So this is a no argument method. A one argument method, as you hopefully know, inside the parentheses you put the name of the argument, and then the two argument one. It's hard to come up with what the Java equivalent of the method name is, because Java doesn't have this implicit way to name the parameters. I mean, you obviously have to name the parameters when you define the method, but when you're calling the method, one of the hard things to remember when writing out a program in these languages is remembering what parameters what. The nice thing, the Objective-C naming system allows you to really easily see what parameter goes in which position number in the parameter list. So that way you know which one's which without having to look at the documentation for the method that you're interested in. So I just called it message. You could argue that message more message is also the right name. Like I said, the mapping there is not 100% perfect. So, okay, so let's do some real examples. So let's assume that we have a person class that we've defined a person, and it knows everything about people. So we can ask a person object for its age. So this is a really simple method call where we just send the message with age, and it returns back an integer value that's its age. These calls can be nested. Maybe we have a method that defines the father of this person. That presumably returns another person object, which you can then call age on. And so in some sense, this kind of looks a little bit like Scheme, the way the parentheses start to get nested, except that the order is a little bit inverted and that the method is at the end. I wouldn't make that your model for how it works. The key really is to understand that the left thing is the object you're sending the message to, and then after the space is the name of the message you want to send. Okay, and here's an example of a method with a parameter. So we have some array that we can add objects to, and I want to just tack an object onto the end. I can say array add object, some object. Immutable arrays also have the ability to insert objects at a particular point in the array. And so this is an example of a two-parameter object. So we have an array, we say insert object, some object, add index. So you can see that this is pretty readable, right? You know that the first parameter has to be the object that you want to insert, and the second parameter is the index where you want to insert it. So you don't need to remember that you put the object first and then you put the index second. You can tell because that's what the method declaration looks